Hello guys, good morning, good evening, depending on where you are in the world. How are you today? Is everything fine? Let's check if everything is working. Can you please talk to me? Turn on the microphone so in case you have questions, we can interact. Thank you, Boshin. You don't have, yeah, you have a microphone. I'm asking because during the course you might want to ask something, and I want to double check that your microphone is working properly. So if you can just turn on the microphone and speak, any of you? Having problems with the app? Yeah, sure. Yeah. I see all of you have a microphone, so I suppose you can just turn it on and talk. I can also unmute you, so.
Okay.
Yeah.
Am I good now? Yeah.
I hear you.
Cool.
Yeah. Cool. Perfect.
Okay.
Thank you.
Hi,
Thank
everyone.
you.
Thanks.
Well, okay. I suppose that so you hear me perfectly. I hear you perfectly. So let's start. So today we are going to start with V-Ray for Rhino. Actually, it's been quite a while since I've been using V-Ray for Rhino. Since its interface was not so nice and user-friendly as it is now. It was a total mess of checkboxes and buttons and sliders. Actually, it looks pretty cool right now. We are far from the node interface that you can find in V-Ray for, I don't know, 3ds maps, for example. Yes, it was horrible, Martin, yeah. We are quite far from the interface that you can find inside 3ds Max, for example. But in that case, we must be, let's say, honest and recognize that the node interface is not from V-Ray, it's from Max. So actually, it depends on the software that you are using. So in Rhino, V-Ray is still somewhere in between being user-friendly and being nerdy, but it has become quite simpler to use it with respect to the previous versions. In Rhino, in order for you to be able to, I don't know if you already have experience with this plugin and software, but in Rhino, if you want to work with V-Ray, the first thing you might want to do is going to render and select the current render and switch it to a V-Ray for Rhino. Now, up to version number 5, Rhino rendering engine was quite awful. So it was a common scanline render engine with no indirect lighting capabilities. But now if you switch to Rhino render, you already have quite a good rendering engine, which is Cycles. I don't know if any of you works or has ever used Blender, but Cycles is the rendering engine that was created and is actually still effective inside Blender. And it's quite a good rendering engine. So if you want to give it a try with Rhino, you can simply switch to Rhino Render, and everything you do will be managed by the Cycles rendering engine. So it is a full GI capable rendering engine, so it has nothing to envy to other rendering engines. But be sure that you are already working with V-Ray for Rhino. So go into Render, Current Render, and switch to V-Ray for Rhino. Okay? And this basically tells Rhino that whenever you click on the Render button, which is this one, it's just like clicking on the teapot that you have here in the V-Ray toolbar. Okay, so actually Rhino will be using V-Ray. So as I was saying, we are talking about a GI-capable rendering engine. So the main difference, the main property that you will find in V-Ray is that it is capable of calculating indirect lighting. Now, why is that important? Because, and we are going to talk about many things, especially today, but also during the course, because rendering is like photography in the end. So many concepts and many aspects of rendering have to deal with photography techniques and photography details, okay, and the way that photography works. As regards indirect lighting, it is very important for a rendering engine to consider indirect lighting, because it is basically the possibility to consider not only when you have a light source coming, for example, from here, it is very important to consider not only the direct lighting. So direct lighting is the effect that you get when rays shot from the light source hit the surface of any object. So this is direct lighting, okay? But when light hits the surface, several things happen, okay? So let's talk a little. I'm not going to go very deep in this, but it's like analyzing the physics of light, okay? We are going to give a quick look at this aspect. So this is the direct lighting effect. And this is, let's say that, let's give names to these rays so we can recognize it. So this could be, let's say, direct light ray, okay? And what happens when light hits the surface of any object with its specific material, okay? So we would also be considering materials. But what happens with this ray? Many things happens. There is a particular phenomenon which is reflection, okay? So reflection is basically the bouncing of this direct light ray with a very specific angle. And this angle is equal to the angle that is formed by the direct light ray and the surface of the object, okay? So we can call this reflection ray, okay? When you have a reflection, you also have to consider what's the power, the lighting power of these rays, okay? So this has a very high power, okay? Because it comes directly from the light source. The reflection ray has more or less the same lighting power that the DLR has, okay? So it is also a powerful light source, let's call it so. When you have reflection, in fact, the object itself becomes somehow a light emitter. So you have light spreading according to the geometry of the object that is causing this reflection. So if the object, for example, has some concavity and it is hit by direct light with this direction, you will have, and this is a reflective object, okay? Like metal, for example, or glass, or whatever object that has a polished surface, a polished finish. So in this case, for example, all the light hits the object in this direction, and then you have that particular phenomenon in which light tends to concentrate towards one single spot, and this is the so-called Caustics effect, and you have a light concentration in here. So this becomes quite like a lens where you have this kind of concentration of light rays. These are reflection rays, and their power is quite high, okay? Because almost all the light that hits the surface will be reflected. So reflective material have this kind of properties. There is a tutorial about Caustics Effect on my YouTube channel, so we are not going to discuss this. Eventually, we are going to implement some caustics during the course, but I'm not so sure because it is a very slow process. So when you introduce Caustics Effect in your rendering, the rendering will start to last, I wouldn't say forever, but it becomes quite slow. Eventually we will not be discussing caustics, but you have a tutorial on my YouTube channel that you can simply follow, and it's based on V-Ray for Rhino, so everything fits with this course. And later on, if you have some questions or doubts, you can write me an email, and we will be discussing this after the course. So reflection is one of the aspects, okay? The main aspect that involves all materials is diffusion, okay? So diffusion is not light bouncing in one specific direction. It's light being diffused in all the possible direction of space according to the geometry of the material, once again. So if the material is a matte material, so light is not capable of passing through the surface, light will bounce on the surface of the material and will be spread and diffused all over this part, this region of space, okay? So now we are drawing like a 2D sketch, okay? But you imagine that this is a surface. So this is actually not a half a circle, it is a hemisphere, okay? So light is diffused and spread 360 degrees in the XY plane and 180 degrees in the vertical direction. So it's a hemisphere. And this is important because in a while we will be talking about the different rendering engines that we have inside V-Ray, okay? So remember this scheme. So this is diffusion, okay? Diffusion bouncing. So these are the effects that occur when direct light rays hit the surface of an object, and this object is not transparent, or it has no possibility of being penetrated by the light, okay? And then there are phenomena that happens inside the surface of the object or through the surface of the object, okay? I'm going to split the scheme because else it becomes very, very chaotic. Okay, so you also have the light ray that hits the surface in this point, and several things can happen as well. The main one, the principal effect that you get with a transparent or a material that is capable of letting light pass through it, is refraction. So refraction, which is the first thing that we are going to see here, is when the light ray passes through the surface of an object, which means physically that light passes from a medium 1 to a medium 2. And the difference between these two is basically density, okay? So let's say that medium 1 is air, and medium 2 is, I don't know, water, okay? So there is a difference of density between these two materials. And this difference of density makes light behave differently. And the phenomenon that happens in the moment that a light ray passes from one medium to another medium with different density, it gets a deviation. Okay, so consider that light will proceed in this direction, but if density is different, then light gets deviated like this with a specific angle. And this angle depends on the variation of density, okay? This is very important because it means that not only light passes through a surface which has some refraction capabilities, but also there is some distortion when you see objects through a transparent material. Okay, we will see this later on when we'll be discussing procedural materials. Okay, so this is the simple effect that happens when you have light passing through the surface of an object. The complex effect is another one. You always have light hitting the surface, and the complex effect is called subsurface scattering. It's commonly known as SSS, and you can think about SSS like diffusion, but inside the first layers of your material, so of your object. Okay, so for example, let's say that an object has this kind of thickness. Okay, and it is a translucent object, so light can eventually manage to pass through the object, but the object is not transparent. So this is typical, for example, of very specific objects or very specific materials like human body, for example. If you put your hand, let's say, between your eyes and the sun, you need a very powerful light source in order to see this effect. You won't see through the end, but you will notice that, for example, at the sides of your finger, you will see some lighting effect. So they become like light pink or reddish. Okay, so that's light subsurface scattering inside your body. Okay. There are also some very particular materials like some liquid materials or wax, for example, which is another subsurface scattering material. Also, porcelain is another subsurface scattering material. So subsurface scattering is um, it's very unlikely that you will use subsurface scattering, but the effect that it produces on very specific bodies and materials is so nice and it's so realistic that you can simply not avoid it if you are rendering that specific type of material. Okay, so it gives you your rendering that look and feel that makes it extremely realistic. Okay. And what happens with subsurface scattering? Well, actually, what happens is that you have light filtering inside the body of your object, but with a diffusion mechanism. Okay, and normally this phenomenon wouldn't reach the other side of the object. Normally, when it reaches the other side of the object, then you have a perfectly translucent material. Okay, but normally this subsurface scattering is an effect that happens in the first layers of your object, like for example in this area. And having light spreading inside your object like this also has another effect. So you must imagine that this is not a transparent body. Okay, so light tends to bounce on it, okay, and diffuse. So imagine that these rays of light encounter the particles of your material, okay, and each time they hit a particle of your material, they get diffused. And when they get diffused in the first layer of your object, then they tend to emit some light from the upper surface. So there is a transition area in your material, very thin, that becomes a light emitter. Okay, and then this makes your material, let's say, shine somehow. Okay, so this is subsurface scattering. It is a totally physical phenomenon that V-Ray can easily calculate and render. We won't be rendering subsurface scattering materials because we won't be working with characters, for example, like I don't know, human skin or something like that. But we will use subsurface scattering for eventually a specific material that I have put inside the test scene, which is porcelain or ceramic, if you please. Okay, so these are basically the main four phenomena that occur when light hits the surface of an object. Okay, and V-Ray is capable of calculating all of them. Well, actually, here we have several things happening. There is reflection, there is diffusion in this first scheme, and then we talked about caustic effects, and then there is refraction, and then there is subsurface scattering. Okay. We will be dealing, of course, with diffusion, with reflection, and with refraction mainly. Okay. But first, the first thing that we must understand, because if we consider, for example, diffusion, reflection, and refraction, they are properties that are a mix of settings between V-Ray settings and material properties. Okay, so if you have a material which is not reflected, then you will have no need for V-Ray to calculate reflections. Okay. Actually, we will be discussing this when we will be talking about materials. There is no non-reflective material, as we will see. But anyway, this is a combination of settings between V-Ray settings and material properties. So As regards the materials, we will be focusing on materials probably starting tomorrow. Today we are only discussing light, okay, which is extremely important. And as regards lights, all the settings are eventually V-Ray settings. So we will be dealing with V-Ray settings today, and we will be testing and understanding how V-Ray handles light. And once we understand this, we will be able to tweak the settings of V-Ray rendering engine in order to produce, let's say, quick rendering for a preview of the final result, or production rendering that will eventually need more time. But we will be able to reduce the rendering time when it is not necessary to get to a very, very high quality. Okay. So first of all, we are going to discuss light behavior in V-Ray. In order to do this, first of all, we must prepare Rhino environment in order for V-Ray to work properly, or for us to work properly with V-Ray. I would recommend, in this case, that you start a new template with large objects meters, or if you want, with small object meters. It depends on the scale of the scene or the model that you are going to draw. But normally, if you are into architecture, for example, you might want to use large object meters. If you are more into interior design, you might want to use small object meters, for example. And the difference between the two is just the tolerance, the absolute tolerance between the two templates. Okay. So actually, I would be using large objects meters because the absolute tolerance is going to be 1 centimeter. So every detail that is smaller than 1 centimeter will not be taken into account by Rhino. Okay. Why this is important? Because in V-Ray, when you consider light, for example, you will be dealing with some units like, for example, watts for light power and so on. Okay, so in that case, you might want to align your 3D model with the standard units that you are going to use. V-Ray is based on metrical system, and so you might want to adopt this kind of units, unless you want to tweak also in V-Ray some settings and you want to eventually convert the values into different units. Okay, so I would start with a template in meters, large objects in meters, and as regards V-Ray, settings are here. This is the new interface. Well, the more recent interface, because this is actually V-Ray 4. So eventually, if you are still working with V-Ray 3.6, there might be some slight difference, but the core is going to be exactly the same. I was working with the V-Ray 3.6 up to I don't know, maybe January or something like that, and still I found some very slight difference between the two interfaces, but it's not that relevant. Okay. So as you can see, actually V-Ray is very empty. Looks very empty. Actually, you might also want to collapse the right panel, and you will see that the interface actually has 2 panels. One on the left, which normally opens the libraries, and one on the right that contains the specific settings of the properties that you are analyzing in the center area. Okay. Now, I would not concentrate on libraries. I'm not I'm not fond of libraries. I prefer to create materials, for example, by myself. Of course, I have my libraries, but only for very specific materials. For example, a couple of years ago, I gave a V-Ray course to a jewelry designer, and he had very specific needs for creating 3 specific types of material. I cherished those 3 materials because it took 3 classes of 4 hours each just to develop 1 material for each class. So if you want, I can share those materials with you, but they are a jewelry material. I don't know if you are into jewelry. Eventually, they can be interesting. So as you can see in this interface, you will have a material section, light section, V-Ray object or V-Ray geometry section, and then you have render elements, and then you have textures. Okay, we will be discussing this later on, something today and some things starting tomorrow, because today we are not going to discuss materials, as I was saying, but we are going to work with lights, of course. So we will be switching between lights and the most important toolbar or panel that we have here, which are the settings of the array. So people normally get scared about the settings tab because it's quite, yeah, let's say scary. So it is a complex set of switches and buttons and, oh, Martin, okay, I will share the materials, sure. Yeah, it's a complex set of a whole bunch of values and sliders and checkboxes and buttons and switches and so on. So it looks like scary, but I do recommend that you do this right now. Okay, so you just collapse everything. Collapse everything, because we are going to take a look at how to concentrate and focus on the important things inside V-Ray. Okay. So first of all, V-Ray allows rendering. Okay, and inside this specific tab, you can decide what engine you are going to use. Now, it's not that you are changing engine. V-Ray is going to be the rendering engine. Okay, but it says, do you want to use your CPU, or you want to use the CUDA, which is basically if you have a CUDA capable GPU, which is normally NVIDIA GPUs, then you can switch to this. I actually have a NVIDIA Quadro on my laptop, so I could switch to this engine, but I won't. I will be using the CPU. Or if you have a RTX, which is another type of GPU, which are more, let's say, modern GPU, then you can switch to this. Okay. Then there is an interactive rendering, which is basically what happens when you switch your viewport to V-Ray Interactive. Okay, so this is something that normally happens when you right-click on your viewport and decide to use a V-Ray Interactive visualization mode. Okay, and it is automatic. You don't need to turn on this switch. Okay, and in case you need it, it will automatically switch. And then there is progressive. Now, progressive is something that eventually you don't want to use. Progressive rendering is something that creates some iterations in your rendering. So it starts from the very first iterations, which is a very, very extremely low quality representation of your scene. And then it starts refining and refining and refining progressively your image. Okay. So when is a progressive useful? Well, it is useful when you just want to have an idea of what would happen in your rendering if you would execute the rendering in that specific moment. Okay. So as soon as you start the rendering, the progressive mode will give you a first representation of the image. Of course, it's going to be the first iteration is absolutely low quality, but it already gives you an idea, for example, of how much light you have in your scene, if it is enough to perceive all the different aspects of your scene, or all the details of the model, and so on. Okay, so eventually I will leave it on for now, but soon we will be switching this off, because we want to concentrate on the real behavior of V-Ray in production rendering. Okay. And quality, this is something that is like working with presets. Okay, so you globally set all V-Ray settings by just moving this slider. So quality means actually what level of quality you want in your final image. Okay, and you, by dragging this slider, you will have low quality, medium quality, high quality. And this will tweak the settings in a very specific way. I would recommend that you don't use this, even if this is something that tends to, many software are into a simplification process. Because as software become like more popular, masses demand that they become more easy to use. Okay. And so you have this kind of general tweaking that basically sets all the parameters of your software in a very specific way in order to get to that specific goal, which is a medium quality. But what's the meaning of medium quality? Okay, it depends on many aspects. So normally, if you have very specific needs, I wouldn't recommend you rely simply on this slider here. Okay. And then there is the update effects. Update effects is actually if you are using some effects in your scene, then this basically tells V-Ray to update all these effects at the end of the image. Now, we are not going to work with effects, but eventually, when we will be analyzing the V-Ray frame buffer interface, I will show you where you can implement this kind of effects. Okay. And then there is one particular feature that I absolutely recommend you start familiarizing and using it, because it is the denoiser. And you will understand the importance of this today, because we are going to look at how noisy a rendering becomes when you start tweaking light settings. Okay, so denoiser is basically eliminating the noise that you have in your final image. Okay, and we will see this aspect in a few minutes, okay, because it's going to be one of the first aspects. So this is basically the main area where you make the big decision for your rendering. Okay, then there are some let's say easier things like camera settings. If you have some previous knowledge about photography, then you might recognize some things here. You have a exposure control and you have exposure value. Now, this is, for example, another slider that tends to concentrate several aspects for your camera. Okay, so we will be dealing not with the exposure value EV slider. We will be dealing with the advanced camera parameters. Okay, so that's where we are going to tweak the parameters of our camera. But for example, depth of field, which is one of the main effects you might want to implement in your rendering, is here. So it's inside the main camera tab. Okay, and then there are some effects here, which are just two, which is vignetting and the lens tilt. Vignetting is that black halo that you get in the corners eventually of the images. It's nice because let's say digital imaging or rendering tends to be extremely precise and perfect. Okay, so vignetting is one effect that was introduced because it is an attempt to recreate some artifact that you get when you take a real photo with a real camera. Okay, so it's like it's interesting because digital rendering is struggling to recover some let's say imperfection, which is typical of photography, while photography is always striving to get to a more perfect result in photography, and this leads to an investigation on lenses and so on. So it's like both of these things are converging to a average result, which is perfect, but with some imperfection. So vignetting is basically the attempt to reproduce some kind of imperfection in your rendering, which is an imperfection of the lens, actually. While vertical lens tilt is something that if you're into architecture, you might know what this is about. Just let me, let's say, simply give you an idea of this. If you are a man like this tall, and you are taking a picture of this building, you have to orient your camera eventually like this, and you have to use a very wide angle for your lens. Okay, so when you take a look at the picture that you get from here, you will have your building like this in your final image, right? So a very distorted perspective. Okay, so this lens tilt, what it does is actually avoid or corrects the distortion that you get from a non-aligned perspective. Okay, we will be discussing this in a very simple way when we are going to place the camera today. We will not be using lens tilt because we don't need it. Okay, but the lens tilt is actually a correction that you get in order to recover the actual aspect of your object. Okay, it is capable of correcting this kind of perspective distortion. Okay, so this is what's the lens tilt. If you are into architectural visualization, you might want to use this. Okay, and then there are the render output, which simply sets the size and aspect ratio of your image. If you want to save the image automatically, you can just turn the switch on, and each time you render something, it will be saved. If you want to create some animation, but the more important thing that we are going to discuss here is environment eventually. And one thing that we will be doing later on when we will start rendering some scene is going to use material override. So we will be discussing these things in a while, okay? And swarm. Swarm is a very important feature. If you have more computers connected to the same network, local network, of course, then you can use swarm. And the swarm actually is capable of detecting the computers that are connected in the same network and use their processors, their CPUs, as computing power for this V-Ray session. So V-Ray is capable of using all the CPUs in a connected network in your, let's say, home or office or whatever, okay? This is very, very important. Actually, I don't have well, I don't have other computers connected to this network, so I will not be able to show you this thing. But if you work in an office or a lab or whatever, then you might want to try this because it's very powerful, and you will, let's say, dramatically reduce the rendering duration if you have access to other computers. But anyway, and then on the right, which is the specific settings of this panel here, this is where things start to become quite complex, okay? So in order to understand these things here, what I'm going to do, and of course you can also repeat everything with me and follow the work. So it's going to be, if you want a practical session, you can work with me. And if you get stuck, just let's say interrupt me, and I will be more than happy to repeat things or further explain things. But anyway, in order to work with this, what I'm going to do, I'm going to create a very stupid thing, a very stupid scene, actually. So let's start to understand how V-Ray works. I'm going to use a rectangular plane like this. And I'm going to create some cube here in order to start understanding what happens when you execute a rendering. So let's open this and have it here on the left. And remember that we are working with a progressive rendering, okay? So if we hit the teapot, or actually the blue sphere here, which is the same, this is what happens. Let's wait for it to, let's say, get to a specific result. You see that there is some refinement going on. You see that rendering image say +1, +12, +16. And each pass is an iteration that tends to eliminate the noise that you still see here, some noise. Eventually, it will not be reaching a very high quality because the number of passes is not set to a very high value. But few observations on this image. Well, first of all, too much light. So you might want to start tweaking light. As you can see, light is the main aspect in a rendering. Okay. So how, well, where is this light coming from? Because we have no light here. So if you have no light in your document, then you must understand where light is coming from. And there are two things that happens when you have no light. First one if you go into light panel here in V-Ray, you would see that there is a Rhino document sun. Now, Rhino document sun is something that is not affecting the rendering. So even if it is listed here, it is not active. You see that its icon is grayed out. If I click on this, it becomes blue, which is the same as switch on this sunlight here, okay? But I want it to be off. So this is not affecting our rendering. So who's determining this light amount here is the environment. If you go into environment, you will see that this is very typical of V-Ray. This has been like this since forever. So there is a specific parameter, and you will see that there is a colored rectangle, which sets this property with a color scale. Then there is a numeric parameter, which sets the same property, but with number. Then there is this symbol here, which means that this parameter is actually textured or not. So this is not textured at the moment because the texture symbol is grayed out, but this is textured. So when you see a bluish, let's say, color, then it means that this setting here is working, okay? And this simply is a checkbox that tells if a parameter is textured, this turns the texture on or off. So in this moment, you see that this is bluish. It means that the background has a texture in it. And this is telling the background that it must use the texture, okay? So if I uncheck this, then the texture is not going to be used, okay? But then there is an environment here with a specific background. And when you use a background, the background will become a light emitter. So let's see what we have in the background. Let's click on the texture, and here is, you see, you have an environment texture, okay? And this environment texture is a bitmap, and this bitmap is loaded from a file, which is C, program file, chaos group, V-Ray, blah, 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 Rhino default EXR. Now, we will be discussing this also. EXR is a high dynamic range image, which is commonly known as an HDRI, DHDRI, which is actually used not only for as a background image, but also for lighting up the environment. Okay, so this is where the light is coming from. And as you can see, this is a, let's say, projected image. So it's like a spherical image. So you will see that there is some distortion here. So if you think about wrapping this image onto a sphere, you will easily understand that there are 1, 2, 3, 4, 5 light spots, like here. Imagine, oh, well, I have a pencil, so I can draw. So imagine that this is the horizon, okay? So this is where you will look at if you look horizontally in front of you, okay? And then you will have one spotlight here, one up here, one here, one here, and one here. Eventually also one here that ends on the other side. And then there is a light, huge light panel on top, as you will see here, okay? So this is a huge light panel, a rectangular panel. And then you have some diffused light panel at the bottom. So it's like the floor, okay? So you have light coming from below, light coming from top, and light coming from all around you with this image here. And that's why you see that here's our cube, more or less it's like here. And you see that only here you are able of, let's say, detecting some surface presence here. All the rest is totally burnt out because of the exposure and the amount of light that we have in our scene. So one thing that I do recommend when you start rendering is go back to the settings, go back to the environment, background, and uncheck this background texture, okay? You can also go in the texture here, and where it says bitmap, you can click here, you see, and you can select other textures if you want. Now, we will be discussing this later, especially with materials, because it's going to be easier. But yes, this is where you define, for example, what type of texture you might want to set for your specific property, okay? So I would uncheck this, and if I uncheck this and repeat, for example, this render, now, as there is no light, you see that the rendering comes out perfectly black. Okay, so this is a good starting point. Even if you don't see anything, this is a good starting point, because from now on you can simply set up everything properly. Okay. So what I'm going to do in order to start rendering something, I'm going to use a light, which is here in V-Ray toolbar. You will see there is a light toolbar, V-Ray lights. I wouldn't use Rhino lights, because some properties of these lights can be used by V-Ray. But if you want a full V-Ray capable lighting, then you must use V-Ray lights. Okay. This is also valid for materials. You might want to use non-V-Ray materials for your objects, but in that case, some properties might not be recognized by the rendering engine, and therefore materials will not render properly. Okay, so if you work with one rendering engine, try to use all the features that belong to that rendering engine. Okay, so I'm going to use a rectangular light. Speaking of which, for example, I wouldn't recommend you work with spotlight tool, for example. I wouldn't recommend you use a point light tool, because they produce some kind of let's say lighting effect, but they are quite unreal. Because if you think about this, a spotlight tool works perfectly in terms of the let's say spot that it's illuminating. Okay, so for example, let's say that you use a spotlight. The spotlight will typically light up a specific area. There will be a hot spot where light will have the 100% intensity, and then there will be a fall off area, and then from this area and around, there will be 0% lighting power. Okay, so this is something that is very nice. The problem is that the spotlight has no emission body. It's just a point. Okay, and this is totally unreal, because at least you have a, I don't know, a light bulb or whatever. Okay, so there is a physical light emitter. So if you want to work with a spotlight, I wouldn't recommend you work with a spotlight. Actually, I would recommend eventually you use another light, which is actually the Ies Light tool, which is a spotlight but within steroid. So eventually we will be discussing this, because it's actually very, very important. And another thing that I wouldn't use is the point light tool, which is somehow like a spotlight, but it emits light 360 degrees in space, but without light emitter. So if you want to work, for example, with a spotlight, you better use an Ies Light tool. And if you want to work with a point light tool, you better use another thing, which is the sphere light tool, which is actually a sphere that you can resize as you wish, and that becomes a light emitter with a geometrical body. Okay, so this is just a quick, let's say, preliminary notice. Don't use a spotlight and the point light. Use instead Ies Light tool and the sphere light tool if you want a more realistic rendering. So I created a rectangular light here. Be aware that rectangular light is a directional light. So you will see that there is an arrow coming from this rectangle. Actually, it is located in the center, but you can see it only, let's say, not from the planar view of the light, of course. It should be a very small dot here, but you cannot see it. So be aware that it is a directional light. So I have it right now on the floor. So it's not going to light up the scene, actually. So I must take it and move it up. So let's move this thing up, and let's re-render this scene. Now we start having a more clear understanding of what's happening. See, I want you to concentrate on the process right now. Okay, so you can see that the image is constantly refining and refining and refining. You can see that, for example, and this depends on the fact that we are using a progressive method. Okay, so this is the meaning of progressive. If you want to have a quick idea of what is going to happen in your rendering, imagine that we are rendering just a plane and a box. Okay, so things, let's say, gets to a final-ish result very quick. Okay, but imagine that you are rendering a very complex scene. Okay, the moment you hit the render button and you have progressive turned on, then you will immediately understand what's the amount of light, okay? Imagine like this, I stop the rendering here. So I already know if the amount of light is correct, if I'm getting the right direction for the shadows and so on, okay? So progressive rendering is good for this. But normally it's not the best option if you want to get to a very specific quality, okay? Because it's very difficult to, let's say, determine the quality by number of passes, okay? If you go into render parameters, then you might want to tweak this parameter here that affect this kind of quality settings. But I will not concentrate on this because it is an indirect approach to render quality. I prefer to rely on rendering engines inside the array. So this is what my personal approach, and this is what I'm going to transmit to you. Okay. So let's turn progressive off. Okay. If we turn progressive off and we re-render the image, now we have a different behavior, which is quite typical. In this case, you might recognize something that it's the nightmare of all digital artists that are into rendering, which are these little squares running through the scene, the image, and calculating the rendering. Okay, so you might recognize there are two phases here in this rendering. The first one is this like progressive behavior here, which is called a light cache building. And then there is rendering image, which is these little squares that are dancing around the image and are basically finishing the image creation process. Okay. After this, you have the finished result. Here it is. Now, we must understand what's happening here, because this is actually how we control quality in our rendering. So V-Ray is the main rendering engine, but it uses several different rendering algorithms inside its workflow, its internal workflow. Okay, and as I told you at the beginning, V-Ray is capable of calculating GI, which is the global illumination or indirect lighting, basically. So, question: is it possible to turn off the light cache preview as in Max? You can turn off anything you want. Okay, so we are exactly going to discuss this right now. Thank you for the question. So global illumination. First of all, global illumination as a global switch. Do you want to consider global illumination? Yes or not? No, I don't want. And if you don't want, and you re-render the image, you will get this. Now, what happened here? What happens here is that you still see some different lighting in the faces of your cube. But this is not due to indirect lighting. It's just due to the different orientation of each face according to the direction from which the light comes from. Okay. So of course, if I have a light emitting like this, okay, and I have an object facing that light, like with this orientation, it will receive a huge punch of light. Okay, but if the object has a different orientation, then rays tend to hit the surface with some inclination. So the power, the illumination power, is reduced by the inclination between the light of ray and the object that is being hit by the light ray. Okay, so this is pure diffusion. This is pure, let's say, illumination depending on the orientation of our geometry. Okay, there is no indirect lighting going on here. Now, there is some diffusion here, which you might think it's due to indirect lighting, but no, this is due to the fact that we are using a planar light, which is not a concentrated light emitter, it's a diffused light emitter. So just think about it like in terms of you have the plane, you have the cube, and here we have a light source which has this size. Okay, and the way that a planar light works is that it's a surface, rectangular surface, which is a light emitter. And the way that this plane emits light is not like this. It's not like raindrops. Okay, this emits light like from this plane all over this region of space. So let's say 180 degrees below, or according to the orientation of the planar light. Okay, so this means that this particular, let's turn red, this particular spot here on the planar light is emitting light like this. And so this point here is illuminating our cube like here, and it's casting a shadow to this distance, while this one, which is emitting light as well like this, is casting a light ray that reaches and casts this shadow here. So that's why you have this transition. The area which is immediately close to the base of the curve is actually black. And then you have transition here of shadow from darker to lighter, because the light emitter is not a concentrated light emitter. We can simply take a look at this. If we go into lights and turn the rectangular light off, and then just grab a, let's say that something that we are not meant to use, but I'm going to use a spotlight so you can see it in action. So I'm going to grab a spotlight. Remember, the spotlight starts from the target, not from the light emitter. So base of cone, I will place the base of cone like here at the center of the box, and then I will place the radius like here, and then I will set the light emitter to be here. And then the way that you tweak the position is by control points. You select the light, and then select the light emitter, turn it on, up, and then select the target and move it up. And eventually you might want to tweak also the hotspot and the fall off of your spotlight. I'm going to tweak the fall off, so it's going to light up all this cone of our space. So this is a concentrated light emitter. So if I repeat the rendering, you will see that there is absolutely no light transition in the areas that are not directly hit by light. So it is pure direct lighting, okay? So this is good for, I don't know, conceptual renderings or something like that. Volumetric rendering, of course, okay? But there is no GI being calculated right now. The power of V-Ray is actually resides on the fact that it can calculate the GI. So there are very specific needs that that would eventually make you decide to switch off global illumination, okay? I'm going to go back to the rectangular light and go back to our rendering settings. Also, the environment is already set up. It's actually black, so I'm not going to keep it open. And I want to concentrate on global illumination right now. So this is going to be our specific goal. I'm going to delete this, and I'm going to work with this rectangular light here. So global illumination, let's expand this, because this is actually what frightens up V-Ray users. When you see this symbol here, it means you can switch to advanced settings, okay? So I'm going to leave this to simple settings. There is just one slider, let's say white, and it's not grayed out. If you click on this, you will have more aspects, but they are normally related to caustics, okay? The only thing that we are going to use today is going to be ambient occlusion, but let's keep it simple for now, and let's switch this on. So here are the rendering algorithm that V-Ray uses, and they are called primary rays and secondary rays, okay? We are going to discuss this in detail using the test scene that I have prepared for you. Oh, by the way, the test scene link is in the chat, okay? So if I notice that someone connected later, so I'm going to go into the chat window, and I'm going to copy paste once again this link here. So if you didn't download the file, download it. Don't open it right now because there is no need, but we will be using this later on today. Okay. So I was saying, let's concentrate on the rendering algorithm that V-Ray uses. And you can see it is split into two different algorithms, primary rays and secondary rays. Now, let's say that I wanted to control how many light diffusion, how much light diffusion occurs in my rendering. Okay, so let's understand how this thing works in general, and then we will be in detail with our test scene. So primary rays is actually not the direct illumination. Remember that we are talking about global illumination, which is basically indirect illumination. So direct illumination is already happening even if you have global illumination turned off. Okay, so like this. And we are going to discuss indirect lighting. So what happens to light the moment that light hits the surface and gets diffused or starts to be reflected and so on. Okay. Now, global illumination has to deal with diffusion mainly. So what happens to light when it bounces on the surface of a diffusing material? Okay. So if you turn this on, you will have, for example, light rays coming from this panel here will hit the surface of the cube and will bounce and light, for example, the floor. Okay, and you will also have light rays coming from the panel hitting the floor and being bounced around and illuminating the back face of this cube. Remember that diffusion is not reflection. Diffusion happens in the hemisphere area of space around the point that gets hit by a direct light ray. Okay, so if there is a light ray traveling in this direction, diffusion will make the light ray bounce also towards the back face of the cube. Okay, the only thing that cannot be illuminated by a first bounce of light is the floor itself, because if you, well, actually, if you consider, for example, light hitting the floor, like here, there is diffusion occurring. These diffusion rays can also illuminate this face of the cube. Okay, the thing that cannot be illuminated by the diffusion occurring on the floor is the floor, because light travels in a straight path. So light cannot do this, for example. Okay, so let's see what happens with these rendering algorithms here. I'm going to set secondary rays to none. Okay, and I'm going to use brute force like the only primary rays rendering engine. Okay, so I'm going to render this. You see that rendering tends to become slower and slower as we tweak this parameter, but this is the result with brute force. Now, brute force and Irradiance Map and Light Cache are the algorithms that are used by V-Ray to calculate the global illumination effects. We must understand how they work, okay? But we are going to discuss this with the test scene because in that case, it will be easier to explain technically what happens, because here we don't have let's say, the right amount of object or the right condition to understand the different behavior of these rendering algorithms. The things that we can do right now is work with Irradiance Map as the first rendering engine for primary rays. And I'm not going to use secondary rays at all. So let's see what's the difference between this algorithm. You see that in this case, you will have the famous square bouncing around in your image. And you see that there is a progressive light calculation going on. We must understand how this works, because this is the main aspect that affects the duration of the rendering. Okay, so as Irradiance Map is probably one of the most important rendering engine that you have here available, let's use it because it makes it clearer in order to understand what in this area here affects rendering duration directly. So you saw this little square that are moving around the scene. These squares are called bucket. Okay, so I think all of you already know these things, but let's see how we can tweak V-Ray in order to control this aspect. Okay, buckets are defined in the rendering parameters. So you see that quality also has a bucket size parameter. So bucket size, which is the size of these squares here, affects quality. Okay, so it's a very important parameter, and it is set by default to 32. And it is set to 32, in my opinion, because 32 is a power of 2, and you will see that this makes sense. Okay. Of course, you can also increase or decrease the size of this. It will be like if you increase this, you will reduce rendering quality. If you decrease this value, you will increase rendering quality. And we will going to understand this in a while. So bucket size 32. And let's leave it like this. Okay. And then there is global illumination Irradiance Map. When you select a rendering algorithm here, you will have its settings right below. So you see that there is Irradiance Map here. If I turn on also, I don't know, light cache, there will be also light cache here. Okay, but I'm going to stick to Irradiance Map only for now. So Irradiance Map, it says mean rate, max rate, subdivs, and interpolations. Okay, remember that we are talking about standard settings and not advanced settings. So I'm not going to use advanced settings for now. The thing that affects rendering duration the most is mean rate, max rate. Okay, so how do these two values work? Remember that our bucket size is 32. 32 what? Actually, the rendering is measured in pixels. Okay, so if you go into render output, you will see that our image is actually 800 by 450. Okay, so imagine that all this area here, 800 by 450, is being divided into, let's say, cells that measure 32 by 32 pixels. Okay, so this is what this bucket size means. It means subdividing the rendering region, the rendering area, into squares that measure 32 pixels per side. Okay, what happens inside those 32 by 32 pixels? This is the important thing. What happens is that the light is being calculated inside that bucket. It's not calculated in the whole rendering area. It's calculated inside the bucket. The smaller the bucket, the higher would be the quality of light calculation. The larger the bucket, the lower would be the quality of light calculation. So -3, -1 determines what happens inside that bucket. So if I run, once again, a rendering and stop it, you will notice that here is our buckets. You will recognize that these areas here, like these, for example, like these, you see? So let's take a while just to define these buckets. So these buckets here are 32 pixels by 32 pixels, right? What happens inside these buckets? They are being divided again, subdivided again into columns and rows. Okay, so let's take some time, but in order to understand this, it's better to work like with details. How many rows and columns do we have here? 1, 2, 3, 4, 5, 6, 7, 8 columns. So if we have 8 columns here, it means that each column measures 4 pixels. Okay. Just give me a second, please, to answer. Okay, so sorry about that. There was a question here. Bucket size also affect the final quality of the render? Of course. Just consider that when you talk about rendering quality in V-Ray, it means mainly light calculation quality. Okay, so almost everything in V-Ray is about light. So rendering quality is based on light. Also, there is a typical behavior that eventually you might have noticed when you use V-Ray. It doesn't matter in what inside which software. It can be 3ds Max or whatever. If there is more light, then rendering becomes slower. Okay, so this is normal, and that's once again a demonstration of the fact that everything in V-Ray has to deal with light. So saying that we can affect light quality means we are actually affecting rendering quality. It's basically the same thing, more or less, because we are not talking about materials and so on. But as regards photorealistic rendering, which means actually photorealistic doesn't mean that it looks like a real photo. It means that light is being calculated properly or in a realistic way. So it has to do with with light calculation. Okay. So yes, absolutely, bucket size affect the final render quality. Now, this is exactly what I was about to discuss here. So you see that if we do this rendering right now and we stop it, we see that the bucket, which measures 32 pixels, is being divided into areas, smaller areas, which measure 4 pixels, 4 by 4 pixels. Okay, and they are 1, 2, 3, 4, 5, 6, 7, and 8 columns and 8 rows. Okay. Where does these values come from? They come from these values here. Okay, so if you think about mean rate -3, -3 means take the bucket size and minus. Minus means in rendering in V-Ray language, minus means subdivide, basically. Okay, so when mean rate is set to -3, V-Ray knows that the bucket area must be divided or subdivided into a value that is set by this value here, the 3. 3 means 2 at the third. 2 at the third is 8. So this -3, which is this one, is actually telling V-Ray to take the bucket size 32 by 32 and subdivide it into 8 sub areas, 8 per side, of course. And of course, if you do this, you will have 32 divided by 8. You will have this 4 pixel side for this smaller area. Why is this so important? Because actually light calculation is not occurring in the bucket. Light calculation is occurring in these smaller squares here. So that's why if you, I don't know if you ever tried this before, but if I take mean rate and set it to, let's say, of course, if this is the power of 2, okay? So 3 means 2 at the third, it's 8. If I set it to 2, then I will be using the power of 2 will be 4, okay? So if I render this once again and stop it, you would see that now we have smaller little squares, okay? And if I set it to -1, if I set it to -1 and I re-render this once again, you will have even smaller squares. Now these squares measure 2 by 2 pixels, 2 at the first, okay? What happens if I set this to -5, for example? If I set it to -5 and hit render once again and stop it, you will see that inside our buckets, regions are becoming larger. Now, the problem, what is the problem? The problem is that we have mean rate and max rate, okay? So when you have a difference between mean rate and max rate, V-ray considers all the passes between -5 and -1, which are -4, -3, -2, and finally -1. But if we set this to the same value, -5, -5, and we hit render once again, and we stop, here you will see exactly the division that occurs at one specific value of mean rate and or max rate. So mean rate -5 means subdividing the bucket into areas. This is the minus effect. And then there is 5. 2 at the 5th means 2 at the 3rd is 8. 8 by 2 is 16. And 16 by 2 is 32. So we are basically considering the size of the bucket has become the area where light is being calculated. What's the problem in this case? The problem in this case is that if you consider this window here, which is our rendering region, okay, the whole viewport. Now, if you subdivide this area here, you subdivide it into buckets that are 32 by 32, you probably have this size for your bucket, okay? If you consider that by mean rate and max rate, if you consider that the area where you are calculating light is set to exactly the size of the bucket, then light will be calculated in this region as if it was a, let's say, uniform region in your 3D model. So for example, what does it mean? It means that you will have buckets running on this plane where you have only the surface of the base plane. In this case, light information is being calculated, well, quite well, right? Because there is no particular effect going on, like in this area. But what happens when you have a bucket in this position? And you make only one light calculation in the whole area. Inside this bucket, you will have two different regions of your model. A part is going to be the base plane, and another half is going to be this face of your cube. So there are two different light conditions that are basically being calculated like one. So this is going to approximate the calculation of light in a weird and awful way. Okay, so you can do this. You can simply set the bucket size or the light calculation area to a wider square. But if you do this, there are two consequences. The first one, the rendering becomes very, very fast. So you can see that we are already rendering the image. Okay, the pre-passes lasted nothing. Okay, the secondary effect is that light calculation is not so, let's say, good. So you might start to notice some artifacts. Now, remember that I told you that this scene is not the best option for viewing this aspect, but there will be the possibility to double check what I'm saying in the next scene that we're going to use. Okay, so what I want you to understand from this thing here is that if you use minus before this value, it means that you are refining light calculation, because you are taking the bucket and subdividing the bucket into smaller areas where actually the light calculation occurs. Okay, and we will see what light calculation means later on. Okay, and with the number itself, you decide into basically you decide the size of the rendering region. So normally this is set to -3 to -1. So -3 means that you will be working on small squares that measure 4 pixels per side. Okay, sorry, 8. If you take this and set it to -3 and stop it, let's double check. Yes, there are basically 8 pixels per side. My bad. I think I made a little confusion before, but this is the bucket. Okay, this is the bucket. Is being divided into 4 areas. So 32 by 4 is actually 8 pixels. Okay, so 2 at the 3rd. So this is actually what happens with this value here. So the thing is that the higher, well, given that you are using negative numbers, the higher this value, the lower will be render quality. Or the closest you get to 0, the higher will be render quality. What happens if I, for example, tell V-Ray that I want to calculate light for each pixel? In order to calculate a light for each pixel, it means that 2 must be 2 at the 0, because 2 at the 0 is 1, okay? So if I set this to 0 and 0, and I hit render once again and stop it, you will actually see that here we are taking the bucket and it's going to be subdivided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And you see that we have this, actually there is light as some, let's say, uniform behavior here, so you don't recognize exactly the pixels, but you are working with within each pixel of your image, okay? So in this moment, if I run the render and let it go, you see that these buckets move quite slowly, okay, inside our rendering. See how much time they need to switch from one region to the next one. Because light is not being calculated inside 32 pixels, it's going to be calculated inside one pixel by pixel, actually, okay? So this is very high quality for a render. Okay? Normally, you don't want to render like this. And what happens, for example, if you turn this number positive? What happens if you render like with mean rate 1 and mean rate 1? This is actually a nonsense. You don't want to do this. But what happens in this case is that if you execute the render, you would see that it becomes slower and slower. If you do this with a real scene, the buckets will hang forever in one single area. Because what you are telling V-Ray now is that it must perform more calculation per pixel. Okay, so this is the meaning of positive numbers. And performing more calculation per pixel, well, actually, supposedly it increases the light calculation, but is not useful for a standard, for any standard need that you might have. Okay, so you see how slow it becomes. So if you increase this value, you tend to increase the quality of your rendering. I wouldn't recommend you go higher than -1. Okay, so don't go higher than -1. So it means that you are rendering, calculating light inside regions that measure 2 by 2 pixels. Okay, it's already enough. And remember that this is not an absolute value. Okay, everything depends also on the size of the image that you are producing. That's why, for example, if you render an image at 4K, like 4,000 by whatever, then you will have more buckets inside. And if you subdivide with -1, -1, there will be more and more a smaller area measuring 2 by 2 pixels inside a wider image with height. Okay, so that's why everything affects rendering duration. Also, the final size of your image. Okay, so normally, if you are working like you are still in the process of I don't know, defining lights and creating materials, and you want to understand if you are working towards the right, if you're in the right path, you don't want to create rendering with this kind of detail as regards light calculation. Okay, you just want to have an idea of what's happening. So if you want to have an idea, you can also set this thing to -5, -5, and you don't waste time rendering like performing some rendering studios. Okay, so you see it's very fast. You have an idea of the amount of light. You can see that there is too much light, even if you are not creating a super high quality rendering. Okay, so decrease these values if you want a quick look at your scene as regards the final render, and increase them when you want a production render. Okay. Then there is subdivision interpolation, and we will be discussing this inside the test scene. Okay. What happens if I switch to light cache? Because light cache is another very common rendering algorithm that is used in, especially in architectural visualization. because of one particular reason, we will be dealing with this also inside the test scene. So light cache, you see that it changes totally the properties of the details, the settings. There is nothing similar to Irradiance Map in the light cache settings. And also, if you execute the render, you will notice that the pre-calculation is actually completely different from the Irradiance Map. Okay, so and normally light cache is always used in combination with another rendering engine. So you might see, for example, there are several different approaches. Many people use light cache brute force. So you will notice that you have this light cache behavior first. Then there are the buckets, and then you start having some result. If you use secondary rays like brute force like secondary rays, you will see that there are the two rendering engines here. And this makes it clearer when brute force is not the only rendering algorithm and it works together with another rendering algorithm, then you will see how it works. Because also brute force has its settings, okay? Normally, what I do recommend, for example, is if you are doing some interior scene, for example, I wouldn't use light cache as the primary rays because light cache rendering algorithm is a rendering algorithm which is based, well, let's say this is a very generic definition, okay? But light cache is basically depends on the camera position. And it's not, let's say, the first element that creates the light casting and the light quality are not the lights, it's the position of the camera, of the viewpoint. Okay, so if you are into interior rendering, for example, the main difference between interior rendering and exterior rendering is the level of details that you have in your geometry, in your 3D model. Normally, if you are into an interior scene, you will have many objects, and then each object has its own level of detail and so on. So it's a very complex scene normally, and you want the light to let's say respond to that complexity, to that geometrical complexity. So you want, let's say, some contrast inside your image. You want let's say some specific light behavior. And light behavior in an interior scene is mostly determined by the position of lights and the quality of lights that we are going to discuss also. So in that case, I would recommend that you switch to Irradiance Map and brute force. Why? Irradiance Map gives you the possibility to control the quality and speed of the render, and brute force, in combination with Irradiance Map, will have these specific settings here. So if I re-render the scene with Irradiance Map and brute force, I get this result here. Which is not the same if I don't use, for example, the secondary engine. It's not the same because these areas here will tend to be darker because there is less light getting to this area. What does it? Why this is happening is because you have the floor, you have your cube here, and you have light coming from this direction. Okay, so primary rays means that there is direct illumination that is reaching this point here. Primary rays is the primary bounce of light. And the primary bounce of light happens with diffusion, as we were saying. Okay, so there is a light ray, or there are light rays that can get to this part here. If there is no secondary rays, light dies on this spot here. But if you turn on secondary rays, with whatever rendering algorithm you might want to use, then you say that light can also bounce again and leave the surface and go illuminate anything else in another position of your scene. Okay, so if you turn on secondary rays, you are extending illumination for each direct light ray. You are extending illumination to first bounce, which is this one, and as many additional bounces you want to consider. And the most effective way of doing this for an interior scene is using brute force, because brute force says exactly how many secondary bounces you want. So if you only use one, light will be able to bounce once more, with respect to the primary bounces that are determined by the Irradiance Map. So what happens here is that if I increase this, I reduce the contrast in my image, because light tends to bounce around several times. But if I make light bounce as secondary rays just once, then light will die immediately after the second bounce that it makes. And so you will have more contrast in your image, okay? So this is the thing. If you work in an interior scene, try to use Irradiance Map brute force if you want to take control over the contrast of your image. But if you want to have some nice mood, for example, you might want to switch to Irradiance Map Light Cache. Okay, so in that case, you will have a smoother representation of light, a softer representation of light. You see how this area is no longer receiving that type of high contrast. It is getting more gray than black. Okay, so this is the main the principal behavior of this rendering algorithm. Of course, there is a lot of maths going on behind these names here. We are not going to deal with that, because it would be boring and a very long process. But just stick to these settings, more or less. So interior scenes, if you want, if you are working in interior scene, Irradiance Map, use Irradiance Map as the primary rays, and then use brute force if you want to keep contrast under control, and use light cache if you want a softer aspect for light distribution, like a specific mood. Okay. The only thing that I would recommend when you use light cache, as you can see, light cache changes the way that the image is being produced inside the V-Ray frame buffer. So you have this progressive aspect of the image definition. The only thing that you might want to take into account in this case is the sample size and the subdivs. Okay, you can also use or take or consider the retrace, but the main aspect are the first two. Now, subdivs is actually determining the general quality of the light cache calculation process. And then there is sample size, which is set to a very small value, but it is set with relation to the screen space. Okay. If you want a very specific control as regards light calculation, then you might want to switch to word units, which means that you are going to, well, light cache is actually going to take a sample of light. If we are working with meters, for example, the 0.03 means 3 centimeters. Okay, so if you switch to word units, then light cache is going to sample light with a separation, with a distance of 3 centimeters from one spot to the other one. Okay, so these are the main two aspects that you might want to take, let's say, into consideration with light cache. But normally, I would say that if you stick to screen space, eventually you might want to decrease this by 1/100th of a unit. But this is if you want a more precise light calculation with light cache. Of course, each tweaking that you do here will result in a longer rendering time. So do it only if you have some specific need, okay? Let's stick to the default right now. And going back to Irradiance Map, what we are going to do right now is finally leave this well, actually preliminary scene that we were using, and let's go back and finally let's open our V-Ray Rhino scene start. Okay, no, I don't want to change anything here. So this is an interior scene Not because it's more important than an exterior scene or a still image or something that or a product photo or whatever, but because it gives us the possibility to analyze several aspects of a rendering. Okay. So you would see that in this image or in this model there are some things going on. There are two separated environments, two rooms, communicating with a door which is open. So from one room, which we can see the other one. So the first thing that we want to do here is place a camera. Okay, so you might know that Rhino doesn't handle the cameras like, for example, 3ds Max. There is no camera object in Rhino toolbars. Okay, so camera is something that happens when you move around the perspective view. Okay, and if you go into the perspective view and you have nothing selected, and you go into perspective view properties, you would see that there are some camera properties here, which are the camera position, the target position, the camera lens, the rotation, which is basically the tilting of the camera, and so on. Okay. The camera is normally invisible unless you go into the perspective viewport. So it's the active viewport is perspective, and you hit F6 in your keyboard. And in the remaining viewports, you will see the camera is now showing up. So this point here is the camera. And then there is the camera target, which lies at the center of the rectangle, which represents the base of this pyramid here. This is the camera target. This is the global, let's say, handle for the camera. So use it if you want to displace the whole camera around. And then there is this one, which is actually affecting the size of the camera. And this is going, well, actually, this affects the rotation, if I am not totally, no, this is the size, and this is the rotation. Yeah, of course. So here are your controls. Now, if you want to place the camera properly, it's a mix between working with these parameters here and also with the control point of your camera. So I want to place the camera in the more interesting part here, which is this one. Okay, so I want to make a rendering of this area. And to do that, what I'm going to do, I'm going to take the camera here in the top viewport. I'm going to disable the snaps because I don't want the camera to snap to any object in my scene. And I'm going to work in projection, like placing the camera here in this area, and then taking the camera target, which is this one, and place it like here. If you want, you can use also, let's say, standard Rhino tools to tweak the position of the camera. For example, I want this camera to face exactly this wall here. So orthogonally oriented towards this wall. So I can take the target and the camera point, and I can go here into transform and set the point's coordinates, like in order to have the same X. So if I need same X, I can simply now click in the point where I want to place the camera and the target, and that will be aligned vertically along the Y direction. So I want to place my camera like here, for example. And now what I need to tweak is just the height of these points. So either I go in the right viewport, and then I move the camera down, and then I take the target and eventually move it up so I'm not facing toward the floor. And then I can do, for example, this. If I want a more, let's say, direct control over these settings here, I can go back into the perspective viewport where I find the camera position and the target position. You see that the X location is 288 like the X target position because I aligned the point, but I want them to stay at a height, Z location. Well, actually I am 2 meters tall, so this could be my point of view inside the room, but I would say 1.75 is the standard, or 1.70 if you want. And I will place the target at the same height in order to have a perfectly orthogonally oriented viewpoint with respect to this wall here. And I want to this camera to be able to see from the window to this door. So in this case, eventually I can try and move this away from the opposite wall and start to see something here, which is the door. And I start to see here something from the other room, but I don't see the window. So in this case, what I want to do is go here in the perspective viewport and change the lens length. So I want to increase the width of my field of view, which means that I have to decrease the lens length. So I'm going to use, for example, 35, and you see that we already have quite a good look at everything that we need. And eventually, for rendering reasons, which is not like I'm not talking about standards for architectural visualization, I can also take the whole camera and move it like a little downwards in order to take a look also at the floor. So I can grab the connection between these elements here and the floor itself. Okay. So this is the camera, the first shot that I want to create in my model. Now, as I was saying, there is oh, and by the way, you see that moving things. I also changed the Z location of my target, which is no longer equal to the Z location of the camera. So I'm going to set this to 1.21 as well. So I avoid vertical distortion, okay? Which is basically I'm creating a perspective with one single point right now. So this is one shot, but I also want to implement another shot here, which is going to be totally different. So how do I save this particular camera position? I go into here, which is named views. If you don't have this tab here, you can click on this gear and you will be able to turn on the named views tab. Or if you please, you can go inside this view menu here, where you will also find set view and named views, and it will bring you to this tab the same. So select the perspective viewport, which is basically representing the camera positioning results, and then hit the Save As button, and you are asked for a view, which is basically the name of the camera, if you please. So this is going to be interior 01, very representative. And so this is now saved. If I do this and double click here, I go back to exactly the view that I wanted to consider for my renderings. I do recommend that you take this viewport here and you eventually, if you want, you can see the camera object in Rhino by turning Show Name View widget in here. So you see that the camera actually shows up. And you can lock named views, so you don't have any possibility to change the camera position, because if you show the widget and you don't lock it, you are capable of selecting it and move it around, and you lose the perspective that you have created. Okay, so if you show this in order to have an idea of the views that you have already created, then lock it, because else you have the risk of moving the perspective, and once you move the camera, you lose the perspective. Okay, and you have to start from scratch. So once you have this, you see that these control points here are still visible, because I still have the F6 options activated. So if I go back into the interior 01 or perspective view and hit F6 once again, then the actual camera widget disappears, and I only have the saved, the named views camera widget visible. Okay, which is, by the way, blocked. Okay, so this is the first scene that I want to create. So first of all, I'm going to save the model. Okay, because this is something that the named views are saved with the model. If I don't save this, I lose once again the named view. Okay, so if I am like in this situation, now you see that my windows have also glasses. Okay, so and these glasses here are all grouped together. There is just one window without glass. Okay, and it is this one. Now we are not defining materials yet, So what happens is that these surfaces here, or these little boxes, because they have thickness, they don't have a transparent material assigned. Okay, so they don't let they cannot let light pass through them. Okay, so if you are in interior scene, the only way that light can enter these rooms is from the only window that has no glass, which is this one. Okay, like in this corner here. So we will have light coming from our right in our rendering, not here where you see the window, but closer to us. Okay, now let's go back to V-Ray, because we changed file, and our file has its own rendering settings. So rendering settings are also saved within Rhino file. Okay, so next time you open this file, you will have Rhino V-Ray settings for this file. This includes, of course, materials and light settings, and eventually other lights and so on. Okay, so what I want to do here in this scene, first of all, I want to turn off progressive, because I want actual calculation of global illumination. Okay, and I'm working with an interior scene. Okay, and therefore, first thing, the global illumination, of course, is activated, and I'm switching to Irradiance Map. And if you want to have control over contrast, you might switch to brute force. If you don't, you can leave light cache. Remember that in this case, light cache gives you a softer distribution of light, so the mood is totally different. Okay, we are not going to talk about image composition and the mood and so on. Okay, this is something that eventually is more related to a compositing or post-production subject. Okay, so we are going to concentrate on V-Ray settings here and V-Ray behavior. I will leave the rendering aspect not to 16:9 widescreen, which is something that eventually, if you have a full HD monitor or screen with this aspect ratio, then you might produce a rendering that fits exactly in your area. But I will switch to match viewport. Okay, why? Because if I switch to match viewport, I am rendering exactly what I see here. Okay, so if I change the aspect ratio, the rectangle will fit inside this window, but eventually will leave something out of the image, especially here at the sides, on the right and on the left. If you want to produce some image with a specific aspect ratio, like for example 16:9, then you might want to go into, select the perspective viewport or the interior viewport that you are using, go into its properties, like here, and switch from view to save frame. And then you can activate the show same frame in the active viewport, so you know exactly where your rendering is reaching in your scene. And you can see that, for example, if I leave this to 800 by 450 or whatever size that has this aspect ratio here, the window will not fit inside the image. And I will reduce the amount of door that I am seeing here on the left. Okay, so eventually, if you want to recover the visibility of the window and of your door, there is no room for the camera to be displaced further vertically. So the only thing that you can do is go back to your viewport properties, go back into view properties, and reduce the lens length a little more. So let's switch to 28. I normally tend to use real life lens lengths. Okay, so of course you can use, for example, 29.5, but I wouldn't recommend you do that, because normally the human brain and our eyes are used to some particular or some specific settings, let's call them so, when we see, or when we see reality. Okay, so I wouldn't use non-standard values even when you are producing renderings, because else the observer or the user will notice that something is not right. Eventually, he or she doesn't know what's wrong, but it detects that something is not working properly. Okay, so try to use always, or as much as possible, real life values in your rendering, or your real life settings. Okay, so my camera lens and distance to target are locked in black. I can change it. Why? Eventually, because you're not in your perspective viewport. So if you go, for example, in the top, you see that, for example, this is grayed out because this is not a perspective view. Okay. In my case, for example, what I did right now is that I switched, or I changed the lens length. Okay. But remember that we have a named views that is still using the old camera settings. Okay. So what I'm going to do right now, I'm going to unlock this, and I'm going to select, well, it doesn't matter if you select it or not, but if you want the same name, then you save this new perspective with the same name. Rhino asks if you want to overwrite the existing settings, and then you have the new settings of your interior 01 saved in your camera. Okay, and I will lock it again. So this is our first camera. Okay, it is saved. I'm going to save it back. So if I render with a 16:9 aspect ratio, I know that I can see through the door, and I have my window appearing inside the image. Okay. Now, save frame also has some additional lines. This is something that you might want to consider if your rendering is made for, I don't know, television or something. This is something that normally has to deal with subtitles positioning, or titles, or whatever. Okay, but we are not going to discuss this in detail. The save frame is something that is less complex. So yeah, the camera is already set. We have the global illumination settings already, let's say, working with Irradiance Map and light cache. One thing that I do recommend to do in this case is, and we are going to do this because it's part of the preliminary part of a rendering, which is the global settings. Okay, so what I'm going to do is basically implement a process that can help you through the definition of the final image, okay, step by step. So you notice that the first thing that we did, we deactivated the progressive rendering. We set up the primary rays and secondary rays and rendering engines to the proper settings, because we want an interior rendering with some soft light mood, so Irradiance Map light cache. And we already set the render output, and we placed the safe frame, so we have visibility of the environment under control. The next thing is activate material override. Now, this might sound like why? Material override is a very good way of defining or introducing light studios in your scene. Because the first thing that you might want to do is tweak lights in the scene, okay? And if you want to concentrate on lights, the worst thing that you can do is have materials in your scene. For many reasons. First of all, if you have materials, rendering tends to be slower, because there are more properties being calculated in the scene. And the way that materials affect light is very particular. So each material interacts with light in its own specific way. So it's a very complex calculation going on when you have materials, okay? And if you want to concentrate on light, it means that you want to concentrate on light position, light intensity, light color, and so on, okay? And if you have materials, this is disturbing for as regards Light Studio. So activate material override. And what happens here is that all your objects, all of them, are now rendered using this override color, which is well, let's say it's not a mid-gray, it's something more light than a mid-gray. If you want to see this, for example, in RGB, not between 0 and 1, but between 0 and 255, then you switch here. And you will see that it is a gray 188, okay? So it's quite light. Now, this is something that has to deal with, you are basically deciding with this override color, you are deciding that the average contribution of materials to light diffusion is basically not white. It's something lower than white. It's a light gray. Okay. So it means, for example, this is very normal for an interior because you might have, I don't know, like white walls, for example. But there will be also a floor, which is normally not white. Well, normal, it depends, okay? And then there are several geometries, several objects, each one with its own material that tends to reduce the whiteness of your scene. So that's why light gray tends to be like a good average setting for a material override color. But if your room, for example, has some, I don't know, some weird color like a dark blue, okay, then in that case you cannot work with a light gray as override color. You might work with a darker gray, okay. So tweak the grayness of your override color according to the global let's say tone that you have that you will have in your environment. This is something that you should already know. Okay, there is no improvisation in this sense. So if you want to concentrate on lights, you activate the material override, set up the override color properly. I'm not going to tweak this value right now. I'm going to leave this to a 188 gray. So I'm going to use white walls and so on. And the effect of this is that we are going to have a totally gray image, which is gray is basically not a proper color. If you think about the grayscale, you have some neutral contribution to light. Okay, it is just reducing the amount of light intensity, both in the primary rays and in the secondary rays. The direct ray of light are not affected by this because they travel through air with their power. Okay, so this material here will affect especially the primary rays and then the secondary rays. Okay, also consider that primary rays are more powerful than secondary rays. Okay, so the main contribution to light distribution in your scene is given by primary rays, and then come the secondary rays that tends to fill the scene with secondary light, secondary illumination, which has lower intensity with respect to primary rays. Okay. Also, you can use an override material if you want. Override material is a full material with all the properties that you might want to set up, like, for example, I don't know, a material with not only diffuse color, which in this case is gray, but also with some reflection properties and some, I don't know, whatever material property you might want to use, okay? But this is something that you might do only if you want to produce some conceptual representation of your model, okay? So let's say I want to give all of this material a metal chrome because, I don't know, I want to simulate some scene made up of pure mirror material. Then in that case, I must define a mirror material or chrome material, and I can use it here in the override material. But it's something that normally you don't want to do, okay? So that being said, I also go into environment and turn off the texture, so I have a totally black environment. And we already know that if I render this, and I'm going to save this. So there is override material, there is no light, there is no way that this render can show something. Okay, so you see that everything comes out perfectly black. So what I'm going to do, and with this, we are going to end this first part. What I'm going to do, I have a window with no glass. Remember that even when there is glass, it's actually not behaving like glass because there is an override material, so light cannot pass through the windows. The only window that allows light to enter the room would be this window that has no glasses, okay? So you can see this because there is no isocurve inside this this area. So what I'm going to do, I'm going to detect this window, go into V-Ray Light, sorry, and take Rectangle Light tool and draw a rectangle around this window, like this. You see that I placed the light on the exterior of this wall, and I rotate it 100 degrees so it can project light inside the room, and take it closer so I get more power to go inside of this room. Okay, and this is perfectly fitting around our window. So now we have a light source in our scene. Let me save this as well. And I'm going to render it again. And so we start having some lighting conditions inside our scene. This is the Irradiance Map working. You see that it now says pre-pass 1 of 1. And I'm going to tell you why in a second. So it's not rendering the image right now, it's creating a pre-pass. So the light cache made its pre-pass, which was this dotted thing here. And now the Irradiance Map is doing its own pre-pass. And now there is rendering image, which is basically smoothing all the samples that you see here. So these are the samples coming both from light cache and Irradiance Map. And the rendering image is simply smoothing of all the samples that have been taken during the pre-passes process. So you see that we are getting to the end. And the reason why we had pre-pass for the Irradiance Map is because Irradiance Map has -3, -1. So you see that this thing is lowering the rendering quite much. So because the light calculation quality is set to a max rate of -1, which means, remember, that V-Ray is considering regions that are as small as 2 pixels by 2 pixels. So if you want to stick with 8 by 8 pixel, so give up with some quality and speed up the rendering, then you might want to set this to -3, -3 to tell V-Ray, no, I just want one calculation in a small area of 8 pixels per side. Okay, so if you do this, you can re-render. You will notice that there will be a building light cache phase, which is due to the secondary rays. And once this finishes, there will be pre-pass 101, but it's faster, as you can see, because these little squares are now 8 by 8 pixels. And then there is rendering image. So rendering came out faster than the previous one. Okay, and as you can see, there is no, well, of course, there is difference in the quality of light calculation. And I'm going to just tell you where you can see this, because in large wide surfaces you see no difference, and this is normal. Okay, where you can detect some artifacts due to poor light calculation is here, is in detailed areas like this one. So see this shadow here. There is no reason for having this shadow in this area. So if you have this shadow here, there should be also the same shadow here, because the geometric condition is absolutely identical along this side of the window. Okay, there is no particular need for this shadow to be present here and not here, and then once again here, and then there is this small black area here. This is due to the fact that inside the 8 by 8 pixel, several different geometrical conditions and light conditions were detected, and they were all blended together into one single light condition that might be good for one surface, but not for the other one. And so you have this kind of artifacts here in your rendering. Okay, but it is irrelevant, because with this rendering, I already know that, for example, I have the proper amount of light if I want this kind of rendering where internal lights are off and I only have one window open, and the light that is entering has this intensity, and my camera has specific settings, and I can see everything. I can see all the details. Also, the frames here that are hanging on the wall, I can also see their edges. So I don't need to tweak, for example, light intensity. I don't need to tweak camera settings and so on, because everything is perfectly balanced, okay? With a very quick render, okay? So without wasting time in complex light calculation.